turn off your mic for now. Hello, Kunal. Kunal, hello. I think is not able to hear us.
Do we have a chat option
Yeah,
there?
I actually texted him, but I think he
Okay.
hasn't read it. Yeah, I think he's seen it now. Okay, so maybe I'll just mute him for now. Yeah, okay. Audible to everyone?
Yep.
Okay. Is his internet slow or something? Because okay, weird. Okay, so as of now, we have three components implemented so far. So we have the oscilloscope. We have this is not yet done, and then we have power source. I'm working on wave generator, and Kunal wants to work on logic analyzer. Yeah. So the discussion for today is actually on the UI part of this particular component, wave generator and logical analyzer. Just a sec. Kunal can't hear anything. I'm audible to everyone else, right? Aditya, Ojas.
Yeah. Sort of. Um,
Just a sec. Let's see if we can fix this.
sure.
Okay. All right. So,
I
like
think
us, yeah.
um, you should
You can hear
unmute.
us, Kunal. Um, I think muting him is yeah. See, Kunal, can you say something so that we know you are able to hear us?
I can hear.
Okay, okay. So maybe you can turn off your mic for a bit because it's kind of loud and we are having a bit of noise from your end. Okay, cool. So the thing is, I was going for this particular UI design. Here, this is the uh, I mean, this is the part for the S1 set of pins, S1, S2, which basically generates sinusoidal waves. And this is for the square wave channels. So I mean pins. So square one, square two, and so on. So this generates square waves and something we call PWM, which is I don't know what that is. Some modulation. So basically, what it is basically square waves, but the amount of time the wave stays on high and low can be altered. So that is what we call a duty cycle. So that is what it is used for. So my original design, I mean, what I was aiming for was that we'll have this preview window. This will be basically this graph, this minified version of this graph. So this will be a preview window where, say, you select S1 and S2, both of them. If both of them are on, this is basically the preview button. So if this is highlighted, this basically means that you are seeing the preview of that wave in this window. So we could have that kind of thing. I mean, that is what I wanted to do. But the problem is, this works fine on high resolution windows, but if I go for something like this, this is 1280 into 800, so that is more or less like a low resolution monitor. Cannot go lower than that. We are not aiming for devices lower than that. So in this case, as you can see, we are almost hitting the toolbar. And the problem is there is one more button that needs to be added here, which is basically toggling between the PWM and square mode. Now, if we add that, this will be pushed even further and we'll hit the toolbar. So that is something that we need to avoid. So I had to compress this as best as I could, but we cannot go lower than this. So this design is obviously not working because the preview window already has been shrunk to the point where it looks distorted. So I don't think this is a good design. Now the thing is, we can reuse this. I mean, we can have a single preview window and we can have the settings for say square one, I mean square channels and sinusoidal channels here in two cards, and we can basically make the changes here and we can see the preview here. But I don't know, I mean, I I can do that, but it would look a bit monotonous, like you open the oscilloscope and you see something similar, and you then open the wave generator, you see something similar. So I don't know. What is your opinion on that? What should we do? Anyone?
I'd say that similarity is the key to generosity, and you should actually go for it.
So we should have
A
three
single
components. In
preview
fact, the
page,
logical analyzer
and
would
its
also look
components
something
should be
like.
shifted to the website.
Sorry.
That would work, right?
What I'm saying is, if we have something similar to oscilloscope here, and then logical analyzer basically looks the same. I mean, logical analyzer is also a graph, and here you have some settings, so it will also look something similar. And then you have the wave generator that also looks almost same. So I don't know. I'm not against it actually. I'm pretty okay with that because it will take less of work, to be honest. I mean, I'll just have to copy paste the code from there, and I'll just have to change the card values. And in fact, kind of code reusability that we are going for, I'll tell you in a sec.
I think for the user that
It's
will
very
be
reusable.
better.
Sorry.
For the user, the consistency among the devices will be in the instruments will be easier for them to get used to the app.
Mm, yeah, that is actually a positive point. But again, I mean, as this is a desktop app, we have the freedom of making the most out of a computer, to be honest. I mean, what I mean to say is that we can have very fancy UI here, and I think we should make use of it. But at the same time, of course, we should not confuse the user with fancy tricks. So we need to have some kind of trade-off here. So the code reusability that we are aiming for is, I mean, the structure has been done in such a way that the things that are reused. Uh, Kunal, your mic. Yeah. So the reusability that we are going for is, say in the source component we have screen. So this is basically the set of all the routes that we have. So wave generator, oscilloscope, multimeter. I mean, if you look at this, so every time you click on something, the route changes and a particular component renders from this list. So you have settings, logical analyzer, and so on. So uh, the components that are, I mean, the code that is written here is not being reused among themselves. Okay, so say you have written something in oscilloscope, so only the oscilloscope will be making use of the code that you write here. So say you have, I mean, they can interchange the bit of code here, as in siblings, and the oscilloscope, the main component, will make use of the code that you write in the components folder. That is how the code is structured. If you see here, things are imported from slash component and so on, and they are used here. Now, so this is the main structure. Now there are some components that are being used everywhere in the app. For example, you have the navigation panel itself. The whole thing is being repeated for every component, so we will reuse that. Then you have, say, this particular component, the uh, the slider. Sorry, not the slider. The circular input. Now this is being reused here as well as here. This is a modified version, of course. Now, uh, so for components like these that are being reused, we have a separate component folder uh, in the source folder itself. So you have screen, and if you come out of it, there's a component folder. So here we have all the components that are being reused among, I mean, in the whole app. So say we have layouts, in fact. So this is what we are using for every component. So we have, say, for now we have two set of layouts. We can have three or four depending on, I mean, the kind of variation that we are going for. Now, for example, this is the graph panel layout. So we have a main layout component, and then we have the styles for it. And index.js is there for just formality. So if you look at this, the oscilloscope, this is using the graph panel layout for obvious reasons. So here, the graph panel layout, I mean, all it does is basically it will give you a component. Let me show you. Oscilloscope. Here, if you see, I have imported the graph panel layout, and here your graph panel layout will take three components. It will take, I mean, three props. That is how I've designed the graph panel layout, sorry. So here, if you see, I take three props. So one is action buttons, one is settings, and one is graph. So the sole purpose of the graph panel layout is it will abstract out, I mean, abstract out the part where you actually have to place the components in particular position on the screen. That is what it does. So if you inspect element on this, you can see there are three major segments. One is this. This is, I mean, there are three components. So, I mean, three props that you supply. So there are three main segregations on the screen. So here you have a graph. Here you have the settings, and here you have the action button. This is not coming out properly. Just a sec. Yeah, here are your action buttons. Here's your settings, and here's your graph. So, so what we do is we write these layouts, and the part where you actually tell the component where to go. This is where you write that code. So here we do the styling using the say graph panel layout styles, and you write all the styling here, and you just supply what needs to be rendered. That's it. So I say the action button should have two buttons, and they should be placed somewhat like this, and just pass the action button component to this particular layout, and this will place it here. And similarly, the settings, so the scrolling and everything will be handled by you. So you need to make sure that the scrolling and everything works, and just give that component to the layout, and the layout will take care of the rest. So this helps us in two ways. We have basically segregated the purpose of different components. So the functionality can be managed separately, and the way it looks can be managed separately. And we have an advantage that we can reuse this component wherever we want. So there's another, I mean, this has not been reused so far, but this will be now after the discussion. So this is the simple panel layout, which has been reused twice. One is for this. So simple panel layout is like the name says, it's simple. So this is basically placing the component in the middle of the screen. So this, and I think it takes just one prop, which is the main panel instrument cluster. Simple panel layout. Yep, just the panel value. And you can do whatever you want here. I mean, how to place the things. Initially, if you remember, my cards were placed on the right, and later I changed it to being placed in the center. So it was quite simple. I just had to change the settings, I mean styling in the layout. That's it. So this is being reused here. So similarly, if we are planning to have something similar to oscilloscope for both wave generator and logical analyzer will have something similar to oscilloscope. There we don't have an option because it is doing something similar. Now the thing is, in the Android app, we don't have this preview thing. They just have settings and that's it. But I thought that if we have a desktop screen, why not make use of it? And I think we can have pretty simple mathematical operations so that we can generate the waves here to give the user a preview. So I think we can make use of that. Now, if we are going to reuse it, we'll just, I mean, what I would suggest is scroll here and screen, copy this, copy this folder, I mean, create a new folder and change the name to say wave generator, I mean, logical analysis, and whatever code you have here in oscilloscope, just copy paste it there and change the, I mean, start changing the names. So start with that. And one more thing that you'll need to change is in app.js, you have these imports, screen settings, screen multimeter, blah, blah, blah. Just add your logical, oh, I think I have already added. Yeah, for logical analyzer, I've already created a route. So what you need to do is, yeah, here you have the component. So just copy paste the code from oscilloscope to logical analyzer and start making changes accordingly. And then when you are done with it, when you have something being rendered in that route, what you need to do is go to components, and there are these plot parameters, channel parameters, and so on. So for logical analyzer, depending on the categorization of settings, create XYZ parameters and like name them accordingly, and you should have something functional and something looking like this. So it can be done within a day if you want. Uh, I'll be traveling tomorrow, so I won't be able to push any PR. But I think I'll change things to what you guys are suggesting. I think I'll make the changes so that it looks something like oscilloscope. So that way, I'll actually have to make a few changes because this button is not needed here in Wave Generator because we don't have to read anything. We just have to set. So this space will be left empty. So I'll have to think something for that so that we can move these cards rather to the top without wasting space. So I'll have to think something for that. Any other suggestions? Any other questions?
I'm not sure.
For logic analyzer, I had created a rough sketch.
Yeah, I saw that. Actually, the lower set of cards that needs to be ditched because see, when you put something here, you'll have to push this graph to the top, or you have to shrink this graph so that it adjusts accordingly. But we cannot do that because for screens of lower size, you can already guess what will happen. So we cannot do that. Now, if you go for a higher resolution screen, maybe we can, but we cannot afford to lose out on the lower end screen. So putting things in under the graph is not something I would recommend. I would suggest putting those settings here alongside your, I mean, along with the other settings that you have. So like, O just suggested something regarding that, as far as I remember.
He
Suggested putting,
suggested to bring it all down and make the graph bigger.
I would suggest bringing it, everything, I mean, bringing everything to the left. Put all the switches and everything accordingly because we have a lot of space there because we can scroll it as much as we want. So you can have all sorts of categorizations there. 3-4 cards if it's I think 3-4 cards would be sufficient for putting all the settings that you have.
Yeah, it's smaller.
Yeah, and in fact that would help in reusing the component that we have, the graph panel layout.
The graph panel, the action button will be used, and channel
Yeah,
parameter.
yeah, exactly. So you can just copy paste code from there and just see that it works and submit a PR and I'll give a review. We'll
Yeah.
make changes accordingly. Okay.
Yeah.
I'll see what I can do about wave generator. I think we are doing pretty much fine because the actual coding period for GSOC hasn't even started, and we are like roughly done with the UI of major components. Actually, one major component, but the rest can be just copy pasted. So I think we are doing good.
Yeah, it actually serves the base for every component. So
Yeah, exactly. So I think by the end of this month, we can have most of the UI part done. I think like Otis will take care of multimedia. I'm hoping he would,
Yeah, obviously, sure.
and the logical analyzer, like you have said, I think uh, you'll have to invest some time because I think you are switching between Android and desktop, so that
Yeah,
would be a bit
actually,
hard.
I got the intent for entire PSLab, and
Okay,
I'm the only student in that for PSLab. So I am looking at.
don't worry, dude. I'm there for you. Don't worry.
that's Adit.
Yeah.
Okay. So I think he's also interested. So we can get him up to speed. See, if you don't have the board, the only option that you have is working on the UI. So for now, I'll be
Mhm.
taking care of the Python part, even though I need a little help there as well because for the Python bit, we have to experiment first. Then I'm writing code, so that becomes a bit tedious. But yeah, whatever
Yeah,
works.
about that device, which device we have to buy? We have to do we
Yeah,
have to
in
buy
order to, I
whole?
guess, work with Python, you need to have the device itself.
Do we have to buy the whole kit?
You
Uh,
just need actually, yeah, that's a good question. I think you should buy the whole kit because the kit comes with all sorts of sensors and jumper cables and everything.
mhm.
So that actually becomes handy because you'll need that. Maybe not the sensors, but at least you need a few jumper cables, which I think it's better to buy the kit. Not because I'm part of PSLab and I'm trying to market it, but I
But
sincerely think the kit has been helpful. Had I been just given the board, I think I would have been like searching for parts and everything. So that would be problem. I think spending a few extra bucks is not a problem. Don't buy the case, just buy the kit, the thing that comes in the box with all those uh, breadboard and resistors and everything. So that comes in handy. Any other questions?
No.
Okay then. So Kunal, I would suggest that you start copy pasting and changing the component accordingly.
Yes.
Just make sure that something renders on the screen when you click that logical analyzer, and then start making changes.
Hmm.
And put everything on the left side of the screen and the graph as it is. And
Yeah.
yeah, one more thing I actually wanted to share. Initially we just a sec. So if you have seen most of the components, we have the listeners being placed at the top. So top in the sense like here, oscilloscope is the parent component for all the other components that are placed in oscilloscope. Yes. So what we had initially was when this parent component is rendered. So before it renders, sorry, after it renders, component did bound. So we placed the listeners here. So we have two renderer config, two renderer data. Actually, this has been shifted to somewhere else. This is what I was actually going to talk about, but since I have not rebased this particular commit, so this is kind of an old code. Anyway, so say you have three listeners here actually. Yeah, so two renderer status, two renderer data, two renderer config. Now the thing is, two renderer data is being used to communicate with the device for fetching the data of oscilloscope. As you know, the oscilloscope is reading data at a pretty fast rate actually. So that's like sending data at a rate of uh, what was it? Like every 55 milliseconds. Yes. So the data refreshes every 55 milliseconds. So that is pretty fast for the UI to get rendered. So if you calculate it right, I think it sums up to some 20 FPS. So that's pretty high. Now the thing is, when for now, like as you can see here, the code is here. So the thing is, if you have read about React properly, the way the class components get re-rendered is by change in state. So every time you change the state using this dot set state, the whole component re-renders. Okay. Now the problem was, so when I'm reading from the device, and oscilloscope.js is basically this whole screen, this whole everything within this. I mean, the buttons and everything falls under that oscilloscope.js. So the problem is when I'm reading and the graph is being plotted here, uh, I mean, if you open this particular panel and try to move your mouse here, you'll start to see like a bit of lag. You'll notice that actually. So this is because the whole component is being re-rendered just for this graph. So every 55 milliseconds, this was being re-rendered. So this actually started showing lag. So what I did was I moved this particular listener into the graph component of oscilloscope. So I converted this component to a class component. As of now, this is I mean, for this old commit, this is a functional component, but I converted this to class component and placed the that particular listener inside this incomponent amount of graph. So what that did was only this graph was being re-rendered every 55 milliseconds. Now, these components were free, so the lag was gone. So, I mean, if you read the docs properly, you'll find these details. So this will actually help you optimize the code. So look out for these things. So you'll learn more. Read the docs properly. Everything has these details. So check them out. And read about Electron a bit, because I haven't been able to do much of reading on that actually. I apparently found out that in traditional Electron app, we have those IPC renderers, which we are using here as well. But the thing is, the IPC renderer that we are using in the React code is not the exact IPC renderer that a traditional Electron app uses. Here we have something called a remote, which I was not aware of. And it is not advised that we used I mean, we use something like this, but I don't know, we don't have an option here, because for React people have suggested that this is the only way out. But I would actually like you guys to find out about that, like whether we can do something with that, or maybe I mean, what are the problems that we might face in the future using the remote IPC, like remote modules. I think that is what they are called. But anyway, keep reading, keep improvising. Let me know, and we'll just work on the multimeter issues tomorrow.
Yeah,
Because I won't be working tomorrow, but we need progress on the app. So you two, at least Kunal and just you two work on your part.
sure, sure.
And
I just want to ask that I've been working on the toggle, and
hmm,
with that toggle, we have to make changes for the Python script, I believe.
with that
Because
toggle, sorry, what?
yeah, because we have to change the values, count, pulse, and hertz. So we have to change for the Python script also. In the multimeter UI.
Yeah, so that is being taken care of. That is being taken care by the send config
Hmm.
function. So you don't have to worry about that, because when you click on that button, uh, and when the UI changes, after a
Uh,
while, that send config function will be called from within that.
we are we are using actually we have the code that we are using the unit prop, I believe, you know.
Just a
So
multimeter, just
just
yes.
open the settings one for the multimeter
Okay.
settings
Settings
option.
options multimeter. Yes.
So we are using here unit.
Yeah.
Uh,
Yeah.
so in the unit What unit I have to do you look up for that?
I think for now you can just put in random units as, I mean, whatever you feel like. We
Mm-hmm.
just need to make sure that the changes happen as we are actually wishing them to be. Like I said, clicking on the button should clicking on the button should trigger a function to which only the subcategory values are being passed, and the rest is being figured out by the function itself. So focus on that, and other details you can just fill in X, Y, Z. Doesn't matter. We'll get to that when we actually start making the connection between Python and the UI. For now, the
Sure.
major challenges I think we have already discussed in the morning meeting.
Mm-hmm.
So yeah, see what you can do about it. Try to fix it by tomorrow, maybe day after tomorrow, but try not to drag that after that, because we'll start working on linking the multimeter and, I mean, multimeter UI and Python.
I will try to finish by tomorrow.
All right, great.
Yeah.
Okay, anything else? Anyone?
No.
All right, perfect then. Good night.
And
See you guys later.
have a safe journey.
Thank you. Thank you. Ciao, ciao.